testing. Yep, cool, great, perfect. I hope you enjoy the food and the sweets. Sorry that I'm not be as energetic as the previous lectures. I'm actually not feeling very well today, but I will do my best. Okay, cool. The next lecture we'll talk about is continuous integration. Whew. Again, like, how's your iteration 0 going with your team members in general? How's the merge into the master, pull from your peers code? Good. Yeah. So today we'll introduce you to something new that will make this process more powerful, more convenient, less menu things. So to scale a multi-user software project, so think of a large project as in Netflix, Canva, or YouTube. So it's a very large software team. So what if we are pushing to master every day, merging to master every day, and we have a lot of people collaborating on the same project. We have branch, each feature, each box may have a different branch, but maybe we are merging into master a couple of times a day. So is there any way that can automatically help us to make the process less headache? Okay, so this is why we are introducing the continuous integration today. So in the past, traditionally, developers on a team might work in isolation for a while. So for example, you want to have a download feature, and you may work in a branch called download. And when everything is done, after a couple of days, and you push back to, you merge back to the master. So this may have issues because if you are merging in a large chunk of code, be some chances that there's some conflicts already with the master, because the master branch may have already been updated by someone else, fixing bugs or working on other features. So there might be a conflict when you are merging in a large chunk of code, and also time consuming. When there's something wrong, you need to solve it, and the conflicts you may have already survived from conflicts in iteration 1, but in iteration 0. But in a very large project, so we want to reduce the number of such conflicts and make less headaches. Yeah, and we also, again, we want to work agile. We work in agile manner. We want to deliver things faster. And here, continuous integration is one of the best agile practice that helps developers to integrate their code early and often to the main branch, or we say the code repository. So when we merge into the main branch, what we want to make sure is that the main branch or your feature branch or your development branch still works well, still passed all the tests. So we learned about Jest test last week. So we want to make sure that our test can still be passed after we make changes we merge to the master. So with continuous integration, it saves us time by identifying and addressing conflicts early, because it helps you automatically identify if there's something wrong and reduce the time spent on fixing bugs. So in more concrete terms, it helps us make change into the master more frequently and stable. Oops. So the first step, if we want to have continuous integration, automatically merge into the master frequently and regularly, the important thing here is we want to make sure that our test can be passed. We do not want to merge in a broken code. We also do not want our merged in branch makes our master branch broken. So we want to have a complex task. We want to have more than that, we also want the test to be run automatically whenever we make a change to our repo. So if there's anything wrong, like we can identify it quickly, because like each commit is a group of change, right? So we mentioned that we want to make relevant change together as one commit. So whenever we make a commit, what we want is we are notified whether the test can be passed or not automatically, so that we can know straightforward whether there's anything wrong and whether there's any bugs. So we need some service to help with that, like help us monitor our repository and listen to the new pushes to our code base. To oversimplify it, so we want to have some continuous integration that allow us to automatically run this npm run test. You remember npm test? We talked about npm test last week in the lecture. So npm run test will run our jest test. So for example, last week we used the example of the walls. Like we want to remove walls from a string, and we wrote a jest test for that. So we want a service to automatically run this npm run test for us, to run this jest test for us. And we also want some visualization tool, like visual tool, tell us whether there's anything wrong with the test, like when we make a change to the code. And this service is available in the Git platforms. So when we say like push, when we mention about commit, so you know we are talking about Git, right? So we are talking about the version control systems. And this service, like continuous integration service, is available also on GitLab, the one that we are using for the 1531 project. Okay, a little bit overwhelming looking at that, right? But I will explain to you. So you start from here, like this is your main branch, and now you are working on a new feature, or you are fixing a bug. So you create a new branch to work on that, like development branch. So we mentioned about branch in week 2, I think, or week 1, yeah. After that, like when we push a new code change, what we want to have is an automated test. Like in JavaScript, we do not have build, so we only have test. We want to automatically test if this push, this change to our code can pass our test or not. So this is what we want. And then if there's anything wrong, like we see a visual tool like showing something's wrong, we can make change to that. And after we make the change and push to the repo again, it will automatically test again. And then we want to have some visual indicator to show us whether the test passed this time. And if it passed, like it's not a broken code, and then we can consider if we want to merge into the master. So before we merge our branch into the master, we want to make sure the code in this branch is not broken. It can pass our test before we merge into the master. So this is what we want, the continuous integration. So continuous integration is more than automated tests. But automated test is one part of it, and it's the initial step, like the must-have. So how can we do that? How can we have this automated tests? How can we set up continuous integration in GitLab? So every Git website has its own way of handling continuous integration. Here we only care about GitLab. And in GitLab, so let me show you. For example, let's have a look at the lab 03. Let's start with a brand new, like empty blank project. So if you want to follow along with what I'm doing now, you need to create a project within your 1531 repo. Because it's a paid feature, like 1531, like CSE, UNSW paid for you. I will also share this project like I created during the demo today with you after the lecture. So you can also look into that project after the lecture. So here's what I'm going to do. In COMP1531, I create a project, start with a blank project, and now we are at lecture 3.2. I make it internal instead of private, so I'll have a look at that. I create this project. Before I make any change to this project, so normally what I would suggest you do is make change locally. So we do have like editors on GitLab, but I will still clone it. Remember how we clone to locally? Do you remember? Yep. Okay, so what I'm going to do is git clone to here. Now I have a new folder created called lecture 3.2, and I cd into this lecture 3.2, make it larger, 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 larger. Okay, so you can see that there's only this README file. What I can do is I can also open this project in your VS Code. I got a feedback last week, asked me to use VS Code more often during the demo because you are more familiar with VS Code. So this is what I'm going to do. I'm not going to use VI open a text editor in the terminal. Instead, I'm going to add file in the VS Code. Document, GitLab. This is the project we just created. I open this project. Okay, make it larger. So now we only have a README file. So to use continuous integration in GitLab, the first step we need to do is to create a YAML file. Okay, so we mentioned a YAML file in the first lecture today, or the data interchange lecture, right? So we create a YAML file, and normally we name it as gitlab-ci.yml or YAML. Okay, so to be able to use continuous integration in GitLab, we need to create this file. Okay, so what we have in this file, okay, yeah, we have all the instructions on the slide. So if you want to practice this after the lecture, you can also follow the slide. So now I'm going to copy and paste this in this YAML file, and then I will explain what are they. So this is a YAML file. So in this YAML file, I'm going to create a couple of tests in this YAML file, and I name them as test job 1 and test job 2. And here we also see stage and the scripts. It may be a little bit confusing to me at the moment, but we'll see what are they. Okay, we are going to see what are they. Okay, so now we've created this gitlab.ci.yaml file. Let's push this to our remote repo, and we are going to see some change to our remote repo. So here's our remote repo on GitLab. What I'm going to do is I'm putting them in the same here so it can be easier to look. Okay, so now, oh, did I add it properly? Lecture 3.2. Where's .yaml file? Okay, so now let's git status to check. So you can see that we have an unchecked file called .gitlab.ci.yaml file. Now let's git add that. Do you remember how we git add? Yep. Can you remind me what is my next step? Yeah, cool. Sorry? Underscore code. Like that?
No, like the character underscore.
Underscore?
Yeah, looks good.
Like that? Well, yeah, there's nothing wrong with that, and it's also pretty fun. However, the commit message, like good Git practice is also important to practice. So what about we make a more meaningful commit message here? Yep. Create a YAML file. Great. Create a YAML file. What's the next step? Git push. Yay, amazing. Okay, so now let's have another look at our remote repo. Let me refresh that. And you will see something different here. Oops. Where is it? Huh? What? Sorry? Oh, the YAML file. Yeah, the YAML file is here. But I'm looking for something else. I'm expecting a tick here. Did I make something wrong? Oops. Where is it? Oh, it's here. Sorry?
What does the little tick mean?
Have you seen the little tick? No?
What do you use it for?
I'm looking for a little tick here.
It stands for successful push.
Yes, it should be here. But where is it? It's so weird. Okay, so I think what I supposed to do is remove this one and see, did I push properly? Git status, git add -- all, git commit -m, update YAML file, git push. Yep. And refresh. Okay, yeah, it's here. So you can see there's something new here. Make it a bit larger. So you can see here's a little new icon showing here. So this means that we have set up our continuous integration. After we have added this YAML file, we have seen this one. And a pipeline. And the test job 1, test job 2, what are they? Have a guess, what are they? Auto test? Yep. So the reason we have a test here is because we have the stage called test. So we can also have multiple stage. And let's have a look. How? I need to push it again. Git add -- all, git commit -m, update, and git push. Oh, it failed. So you can see that whether your whenever you push to it, you can see that there's a new job triggered. So automatically, like whenever you push, it will test for you. And the test they run is what you have written here in this YAML file. So in this YAML file, you are actually telling GitLab what they need to test whenever you push to your GitLab repo. So here's actually nothing, like we are not testing anything. We are just equal, like we are just printing something. So let's have a look. I'm going to git add all, git commit, git push, and you can see when I refresh, the remote repo is triggered again. And when you see a pending, meaning that you are waiting in the line. So who is running this test for you? Like, why are we waiting in a line? So where is this line? So this continuous integration actually run on a virtual machine. Like before, like a couple of years ago, there's a virtual machine sitting at CSE at K17, and that machine actually runs all of these auto tests for us. But now CSE has moved this machine into a virtual, like we now use AWS service. So it's much faster than previous terms. So, but still, sometimes we are waiting in the line because other people are using the AWS service to run the auto test for their test. So we can see a pending. But now we have joined the line and it's passed. And there's some more information we can see when we click on this test. Have you seen something similar to this? Lab? Lab? Yep. So Lab is actually using something similar to this. So you can read some from here. So let's have a look at that. So we are running with the GitLab runner. So runner is actually the machine that runs all these tests for us. It's called a runner. So multiple machine, like we can also use one runner, like we can share one runner. And this is running here on COMP1531 AWS GitLab primary runner. So my auto test is running here. You do not need to pay much attention to that. And getting source from GitLab repo, fetching change. Okay, so here is our test. So we have like this job test something. Why it says this is because we had written this here, like this job test something. Cool. So we can remove this echo this time job test something into, like, for example, npm run tests. We'll see that later. But it's something that you can change, like some scripts you want your auto test to run. You can put those scripts here. But now I only want my auto test to run this script, like echo. Echo means print in Linux environment, means print this job test something. And then you can see here, this job test something, that it's print successfully. The test is successful, it's passed. There are also another job. So we have two jobs here. So here, test job 2. Similarly, it's running on this GitLab server on AWS. And we have 3 equals. So we have 3 jobs, like 3 scripts we had for test job 2. Like the first one is this job test something else, test another thing. This is because this is what we asked the runner to do for our test job 2. Yeah, question.
So once they read all the scripts,
Uh-huh.
that's like, and if the scripts all run perfectly well, that's
Uh-huh.
when like the test job has passed successfully.
Yes, so these are separate tests. So test job 1 is one, test job 2 is another one. So you can see from here, like test job 1 and test job 2, they are 2 jobs. And sometimes you may pass one of them and fail the other. Okay, any questions so far?
Does this also run on branches, or is it just on master?
It can be run on branches, yeah, and we actually suggest you to run on your branch. And one is like a green tick, like that, then you can merge into your master. Yeah, question?
Can you talk about why did it fail before 6 months? Like, why did it fail the last test?
Sorry, what?
Why did the test fail before the last push?
What did I have? So let's try to fail something, okay? Let's try to fail something. Okay, cool. Let's fail with the npm run test, so it can have more meaningful fails. Let me have a look at the slide first. Cool. This is just what we have seen. And we have also mentioned what is a runner. And this is the runner. Yep. Before we see the failed test, let's have a look at some like concepts or theories. It's very shiny. Okay, so pipelines. So we also see pipelines here. So we talk about so pipelines. You can think of it like steps or your jobs to be done. So all the jobs to be done is in your pipeline. So now, what if we want to run NPM tests, like automate the NPM run test using the continuous integration? What can we do? Like now we are just running some like toy tests here. Oh, I need to git pull first, otherwise I will going to see some conflicts. Git pull. Okay, git status. Okay, now it should be fine. Okay, yep, it's been merged properly. Yep. Cool. So what if we want to automate the NPM run pipeline, like having a script called NPM run test? So we have seen scripts in our package.json file. Remember, like we added the package.json file and there was a script and we made some edit to it. So let me show you again. So here, so remember like we added the scripts in the package.json file. So it's similar here. So we can also edit a script here in the YAML file. So YAML file and JSON file, both of them are data interchange language, right? Okay. Before we run, like have NPM run tests, remember that we need to have a proper environment. Like we need to have NPM init. We need to have NPM install sometimes, right? So we need to have this environment set up before we can use this NPM run test. So let's set up this environment in this lecture 3.2 repo. Anyone remember how we can set up the environment? NPM init. Yep, project name, package name, version, description, entry point, test command, git repository, keyword, author, license. Is it okay? Yes. Okay, so after we do that, we have got a package.json file. Anything else we need to do? Actually, there is, but you do not need to worry too much about that because in the labs and also in the major project, we have already set up those for you. But if you want to play with the code, play with it by yourself, and you want to create your own project, so what you can do is you go to one of your labs and you go to one of, like, for example, this lab 3, academics, and in here we will copy the the dev dependencies, because after we copy and paste the dev dependencies, we can use npm install and npm will install all these dependencies for us. Otherwise, we can also just npm install, like just npm install the other dependencies. So here, another thing that we need to do is we need to have a tab model. Yep, tab model. Oops, before main. Actually, there's one more thing that we need to do, but you still do not, again, you do not need to worry about that. Is we need to add this, this file. But in your labs and your project repos, we've add all of this for you already. Just for showing this demo, I'm creating this environment. Okay, so now I can npm install. before we push this change, like the npm package, like the package.json file or the node modules, there's one more thing we need to do. Do you remember what is it? Like before we push? Ignore, yes, exactly. You do need to have this git ignore file in your folder because in all of your CSE disks, we only have 2G for each of you. If you push to your CSE server like a lot of node-module files a lot, you will run out of space quite quickly. So we need to have this .git ignore file, and oops, we put in this file node modules. Okay, cool. So now let's git status, and we can see that the node modules folder is not listed here. And now we can git add all and git what commit -m npm environment, and then I git push. Cool. Great, so let's go back to our lecture 3.2 remote repo. Yep, everything's still passed because we didn't change the YAML file. Like we didn't change anything for the test. So now let's add something about the npm run test in our YAML file. We can start by using the one provided by the lecture slide. This one. Let's have a look, see if it works. Because we do define a stage here called checks. And we have testing in the stage called checks. And we run npm test. Oh, one more thing that we forgot to do. Do you remember what is it? There's something in this package.json file that we forgot to do.
We need to configure the scripts, the test.
Yes, that's right. So what should we put here? Just? That's it?
Oh, you need to put it in the file you're trying to test.
Yes, that's right. So before we do that, we do not have any actually working code in this repository. Like we do not have any test file, we do not have any functions that we can test. So what about we reuse some files that from the Jest test lecture. Okay, again, I'm not going to use terminal. I found like some of you are struggling using terminal. So what I'm going to do is I'm going to use the folders to copy and paste the files. So lecture 3.2, I need to find some file from our last lecture. It was on GitHub. Lecture code environment 1. Do you remember which one we had last time? Testing the walls, right? Like removing walls, and we created a Jest test for that. So I'm pasting them here, so you can see here's the file like we collaborate, like we wrote together last week. Yep, last week. And this is the test. So this is the only test that I'm going to use. So I can just put this test file here. Just lib.test.js. Yep. Okay, cool, great. We've made a lot of change to this repo. So what I'm going to do is I'm going to push this change to our remote repo and see if we can pass the CI, continuous configuration. I'm quite nervous. I'm not sure we can pass that. Okay, so let's have a try. Git add all, git commit, and git push. Let's have a look. Let's refresh the page. And it's working on it. Oh, we passed. Amazing. Cool, great. So you can see here, npm run test. Here's our JS test that we wrote together in the JS test file. Like we had a test called strings with no walls. So let's have a recap here. So in our test file, we had one test called strings with no walls, one test called strings with only walls. So you can see here in the JS test, in the continuous integration, you can also see all the tests has been passed. So all we have ticks before all of the tests. And the test use is only one. Like we only had one test use because in this file we only have one test use, which is here. So only one. So this is one. We can add more, then we can have more test use. So only one test use. And in this test use, we have 6 tests. And all of them passed. Cool. So now let's have a look. What if it fails? So what it looks like if we fail something. So let's remove some of our code in this function here. So what if we forgot to replace all of the U's from the strings? What if we forgot that? So now let's git add all, git commit, and then git push. Now you should be able to refresh the page. And it's pending now. It's pending. You can see the pending. It's orange pending because we are waiting the line. Still pending. Failed. Okay, turned right. It failed. What's in that? So let's have a look. So this one failed. So there's a failed icon before strings with only walls. And here's some more details about the fail. Like expected nothing, but we received a U because we removed the line about replacing all the U's in the strings. Yep, any question? Any questions so far?